So you needed to complete an experiment where you added more cells to the circuit and you took the readings on the voltmeter and the ammeter. Basically, it was very simple setup of one resistor, ammeter and voltmeter, checking the current going through that resistor and the difference across the resistor. So, here's our setup. When you put the ammeter and the voltmeter readings, you would have found that the ammeter readings would have increased and the voltmeter readings would have increased. And you were then, I asked you after filling in a table, and you had to take 6 readings. I've only got 3 here. When you drew a graph out of that, you would have found that they increased in a direct proportion. In other words, you got a straight line out of that. So the more cells that you put in series means that there's more energy being given to the charges, and therefore, if the charges have more energy, they can move faster. So more energy results in a higher potential difference, and moving faster means that you get a bigger reading on the ammeter. So your conclusion: as the number of cells in series increases, the ammeter reading increases and the voltmeter reading increases in proportion. As more cells are connected in series, the voltmeter and the ammeter readings are going to increase. That means both the potential difference and the current strength increases. So how am I going to ask you questions about this? You need to know something called Ohm's law. Ohm's law says that the current through a conductor is directly proportional to the potential difference across that conductor as long as the temperature stays constant. So there's this thing called an ohm, and we learnt about it in grade 9. And an ohm is equal to 1 volt per 1 amp. So in other words, potential, at least resistance, is equal to potential difference over current. And we learned that very simply in grade 9 as well. So if I were to draw a graph of potential difference and current, now you guys know what a R is equal to y is equal to mx plus c graph looks like. So y equals mx plus c. I'm going to rearrange this equation, and I'm going to say v is equal to ri. And if you think about it, the v is then on the y-axis, the r is then your gradient, and the current strength, goes onto the x-axis. C is 0, which means that you are going to go through the 0 point, which makes sense because when there's 0 potential difference, there's going to be 0 current, and vice versa. So it's going to be a straight line that passes through the origin, and the gradient is going to be equal to the resistance. So here's an example. I've put the Y voltmeter and I've put the current strength ammeter onto the x-axis. Let's say I wanted to work out the gradient. So I'm going to say gradient is equal to y2 minus y1 over x2 minus x1. y2 is going to be, let's say, 27. So this point over here is 2, 7, 27. And this point over here, say, is 1, 8 and 18. The other point that's handy to know is 0, 0, because that would be very easy to subtract from. So if I said y2, 27, minus, let's say, 0, I could say 2, 7 minus 0, and I then land up with the fact that that goes in 10 times. My gradient is my resistance, 10 ohms. I double check that my voltmeter V is Y and my ammeter is X, because that would give me resistance. However, they very often plot this graph the other way around. In other words, the ammeter goes onto the y-axis and the voltmeter goes onto the x-axis. And when they do that, when you get the gradient, you don't get the resistance. You get the inverse of the resistance. So you would then need to flip your answer. So let us say that this was the wrong way around. The final step would be to say 1 over gradient is equal to 1 over 10 is equal to 0, 1. But that's not relevant for this particular example. So we've calculated the gradient, it's change in y over change in x, and the gradient of the graph for Ohm's law always represents the resistance. And the ratio of V over I is the resistance, and Ohm's law states that resistance, at least potential difference, and current will increase in direct proportion to one another, and the direct proportion comes from the fact that we land up with a straight line graph going through the origin, and therefore it will be a direct proportion as long as the temperature remains constant.